in a way, the presentation that I'm going to give is about one of the projects of our students. Yesterday, Edward gave a presentation about part of the work that the students performed, and now I'll tell something more about the other components of the system. So all these names here, these are students from Delft University. This is a student from Wuhan University. Actually, he was presenting also here. And in a way, this is a part of our geomatics program. This is a master program. And actually, the second year of the master program, we have a quite large project, about 7 weeks, where the students, all the students from the program, they go to they take some topic to investigate from the beginning till the end. So it's a complete project, and they cooperate with companies, with different universities. And the idea is actually to work in a group and to prepare a product that can be really used for something. So we started with this in 2006, and you see here these are the reports of all the projects due last year. And now they're all available on the website of the geomatics program. This year, it was in September, because of all these developments in Imdoor and because some contacts that we established with Wuhan University, we decided to do something on Imdoor. And actually the idea of the project was to develop a multi-purpose 3D navigation system for one of the largest actually museum in Wuhan, in China. And this we did together with the Wuhan University and some students of Professor Zhu. Therefore, the supervisors were my colleague from yesterday, Edward, Professor Zhu, and me. We spent quite a long time there, something like 3 weeks. The students spent even more. And this is, in a way, a museum from outside and from inside, and these are some parts of Wuhan University. And you already guess why we went to Wuhan. Actually, they have done quite a lot of 3D modeling. The whole city is 3D modeled from above and under the ground. They have also a lot of buildings that are modeled inside. And this attracted us to go to them and use exactly these buildings and see how we can build a navigation system, 3D navigation system, for different kind of users. Yesterday, these are actually the all key issues that students have to concentrate and provide some solutions on them. Actually, the localization was presented by Edward. We used 2 systems for localization. One was developed by Wuhan University based on Wi-Fi fingerprinting, and the other one was on other type of devices, Wi-Fi scanners, and the results were presented yesterday. After that, then we had to decide on what kind of system architecture is appropriate for this kind of application that has to run in a museum. The users that are considered for this type of applications were the normal visitors and the managers of the museum. So the students perform also some user investigation there. They got something like 120 interviews, and on the basis of these interviews, actually the requirements to the system were defined. We made a small trick there. When we asked the users what kind of navigation system they want to have, we didn't give them any other chance than choosing 3D. So they had to choose between different types of visualization, 3D visualizations. They had 3D visualization as bird view. They had a 3D visualization as walking through the building. And they had 2-3 more visualizations, something mixture between. There was also some possibilities with transparent walls and some attractions, landmarks in the corridors, and these kind of things. But all of them were 3D visualizations. There was only one question whether they want to have 3D visualization. No. And actually to this question, about 40%, 35% of the people, they said that they are perfectly fine with 2D visualization on the maps. But we ignored completely these responses and we continue with 3D implementations. So what I'm going to tell you now is actually a little bit about the model of the database, about how we extracted the network and what kind of navigation was performed there, and actually the final application on the mobile device using interface and visualization. One of the very important things that the students were pushed a little bit to do is to make a system architecture that will allow not only visualization and building application only for this museum, but thinking on a more conceptual level, how they can provide building information for the whole city of Wuhan, and how they can organize this data in a database management system, and what kind of data they will need for this kind of for navigation indoors. Therefore, they concentrated very much on using database management system. Actually, the system was server-based with some kind of web services between the server and the database management system, and application that was in two variants, one running on a mobile device and one running on a web environment for the managers of the museum. This is where they spend quite a lot of time, and I will give some information about this. Collection and extraction of the network is also took them quite a lot of efforts to investigate which approach is most appropriate for this kind of application for the museum. And yeah, as I said, I will say something about the user interface and how the 3D visualization was provided on the mobile device. So, when they started developing the application, there was already this localization application that was running on in Wuhan University based on Wi-Fi connectivity. And actually this application, it collects a lot of information. So we wanted to integrate this information about the positions of the user with the information that is needed for navigating the users, because we wanted to provide possibilities to users as entering the museum to be able to select where to go. So we wanted to provide some predefined routing information to some very important exhibits in the museum. So this was exactly this part where some kind of predefined routing was stored in the database. But also it was, we wanted to provide all the data that is needed for the routing and for the 3D visualization. And this all information we wanted to organize in one database management system to be able to make analysis between all these data. So if we have the localization, to be able to say, okay, from this point, go to some kind of exhibit that the user wants to visit. Or if we want to know already what is the routing within to a specific exhibit, to be able to say, okay, this type of geometry we need to be able to visualize the route. So everything was organized in one database management system. We selected PostGIS because the students selected actually PostGIS because it was freeware. It was already used by Wuhan University, and it was provide data types, and it was we had already some experience how to organize 3D information inside this database. So I'm not going to go in all these details about the model, but actually the different classes here that are very much simplified indicate which of them correspond to the different types of information that was stored in the database. This information here about the objects, actually it's only the objects that are exhibits that are exposed in the museum. We assume that the information from CPGML and the 3D model actually, given as a CPGML, will be the geometry that is going to be used to visualize inside the model. Concerning the network, it was really kind of very simple. Network is always simple network. You have edges and nodes, and we didn't investigate anything new. We just decided to use existing navigation network models, and for this purpose we used the PG routing structuring in PostGIS. And actually using PG routing, we had immediately already routing algorithms. The student implemented used actually as the algorithm for this. The interesting question about the network extraction, actually triggered by the discussion that we just had before the break, I decided I included a few more slides about research on indoor navigation and extraction of network. Actually, there is a lot of research. You can see all kinds of different methods based on regular grid, 2D or 2.5D. You can see approaches based on network. It could be considering the doors and the rooms. You can have all kinds of density, different density to the nodes. It could be again 2D or 2.5, 3D. And probably many of you already have noticed that Google has indoor navigation on mobile devices. So, a lot of different approaches. Even we have some research on voxelizing buildings, rooms, and providing possibilities to fly over objects, to fly in the room. So this is the same multi-D building, and this is a walking path that is derived on the basis of the voxels, these 3D pixels. And this one, probably here you notice, goes above this table, in this case, flies on a specific height above the table. So many different approaches. The students actually have to decide how they are going to get from the 3D model some kind of information which they can use to create some type of network. Because the 3D approaches and creating actually network in 3D space is still quite tricky, for them we decided let them use the floor plan. So for them the task was from the 3D model to extract only these surfaces that correspond to the floor plans. And after that, because the floor plans, of course, they were not up to date, still to have some kind of manual work to add some new elements on the floors. And using these floor plans, after that, to extract, to create a network. So these are the SQL scripts. So the information actually is possible to be extracted from the database if you have everything well organized. So far, this process here is automated. This here is manual because they have to correct. But this is the floor plan. How to create the network? What kind of, where to place the nodes that are going to be used for navigation? And considering all different approaches that were shown before, you can use regular subdivision, geometric subdivision, We can try to make some kind of semantic subdivision. You also was talking about it. If it is geometric subdivision, we can apply some regular billing, irregular billing. Which one? So this was a question that they are puzzling quite some time. But finally, we decided to use triangulation, constraint triangulation. It was, in a way, a very appropriate approach for exactly this type of application and building, because here in the middle of every corridor, there were also some exhibits. And actually, the exhibits were on both sides of the walls and in the middle of the corridor. And people, when they walk, they come a little bit here, they stay here, then they go to the exhibit, they come again here, look at this exhibit, go there. And actually, the way of walking simulates very much what you can get from triangulation. In general, if you get this triangulation on a normal corridor, and you get this kind of path, you will never follow triangulation. It's not that appropriate to create automatically a network. You have to either introduce a lot of staying points to be able to make these triangles many and be able to make the path straight what the user might need to do. But for exactly this application, it was perfect. So, on the basis, this step, again, was automatic. Having the floor plans from the previous step, they could automatically derive this network. And actually, they didn't provide all the information for all 4 floors of the building, of the museum, because we didn't have the fingerprint map for the Wi-Fi localization for the whole floors. We have only for 1 floor. But in general, the idea was that we can do this kind of connecting the floor plans by vertical connections. This is actually what exactly Leo also was explaining. Okay, after that, the visualization. For the visualization, we decided for the mobile device to use game engine. And the game engine that the student selected is Unity 3D. And the whole process of extracting data and visualizing them within the creating the file that is needed for rendering in the Android is shown here. It's not that strange. They first create the model. They compute the routing information on the basis of the network that was extracted on the previous step, and they combine these 2 data sets and visualize them on the Android in the game engine. So, for the time being, there was a small problem that actually, for the time that they were working there, they didn't have time to store the 3D model in the database. Therefore, we decided in the last moment to have the model just as a Unity 3D file on the mobile device or on the server and just fetch it when it is necessary. So actually the model, the 3D model was not in the database. Only the network was on the database, and this integration of the 3D model with the network was performed on the file. Okay, the user interface. Very simple user interface. You just have several buttons. You select some of what you want to do. You have predefined routings to some very important and popular exhibits. And you have some recommended routes, and these 2 are stored in the database. But also, you can get either map, and you can look what is happening in the map and try to find out by yourself where to go, or you can request to be located. If you get lost, you can request the system to be located, and from this location to start the navigation. And of course, another information, just textual information. Okay, when you request information, actually we didn't have kind of push service when the person is supposed to get into the building. He gets the app and also has to push the button and request authorization. We didn't have push service for getting the location. Some of the next screen is actually some of the, this is the screen for the popular exhibits, and getting the popular exhibits, actually you get the navigation and it's visualized in this way. You have the point where you start, where you are at the moment, and somewhere here is the exhibit that you want to visit, and this is the path that is complete. This view, as you see, is selected to be visualized on this way because of the results of the user requirements. All of them, 87% of them, pointed this bird view visualization as the most appropriate for the purpose of navigation within the museum. And in a way, if you can, I have a small demo about how it works. They make a video, yeah? Or you have to switch computer. Yeah, that's what yesterday Edward wanted to start with, but we didn't work very properly. So this is the museum. Imdoor and 3D navigation and how can we do it. But if we start really implementing and making small kind of applications and demonstrating these small applications to the people, I guess much faster the developments and indoor navigation is going to develop and to progress. What the students really didn't have the time to do, the idea was to have also the different users, not people only that can walk, but also people that have some kind of trailers or on wheelchairs, so they need to have another part of navigation. For example, use the elevators instead of the stairs. But for this, there was no time to do implementations. Extraction of the 3D network. As I said, the network now was on the floor, so what still needs to be done is how to connect the different floors to the stairs. We didn't have the 3D model really stored in the database, but as we said, we rely on CPGML. This was the assumptions. And in general, there are database management support for CPGML. And the information about the objects, these exhibits in the mobile devices, the students wanted really to have some kind of also virtual objects, some kind of icons that can really in more intuitive way provide the information and attract the people in that way. So, this was a small project. Together with Wuhan University, we tried, and I think it was quite, not I think, but I'm very happy that it was so successful, and that under the pressure of the time, the students really managed to provide actually 3D navigation and positioning and navigation. The positioning localization module of Wuhan University is actually very accurate. They have a separate application which is running also on mobile device, and on this application you can follow, you can see how you are exactly positioned, and the positioning depending on the quality of the fingerprint map, but the positioning is very accurate. In some places it's 1 to 2 meters. You walk and you see your position is jumping around you a little bit, because you have the map and you can see where you can see where exactly you are, but also you can see where the points on from the location on the maps are. And in many cases, the positioning is within 1 to 2 meters, very, very accurate. So, it was a success, and this is what I want to say with this last presentation. And thank you for the patience and for being here.